Our Apollo lander consisted of over 1,500 parts. The descent module was comprised of the outer suspension system, thruster assembly, oxidizer, oxygen and fuel tanks, as well as scientific equipment and plume deflectors. The suspension system was pretty simple, but terrible to build. Honeycombed aluminum sheets acted as the suspension buffer in place of pressurized gas or hydraulic fluid. They were compressed and crushed to provide the damper effect needed for a cushy lunar touchdown. In order to land safely on the moon, the crew needed a robust, reliable descent rocket system. The system functions by pumping high amounts of fuel and oxidizer from the pressurized tanks into the combustion chamber. The pumping mechanism functions by having high-velocity gas pass through a turbine located at the bottom of the system. This causes the blades in the turbine to spin, the mechanical energy generated being used to rotate the pumping mechanism, which provides fuel and oxidizer into the combustion chambers. The Modularized Equipment Stowage Assembly, or MESA, holds the equipment used by the astronauts during scientific missions. Some of the experiments included this crystal-based reflector system, whose prisms were able to reflect beams back at the exact angle they entered. They're still in use today. The Rocket Control System, or RCS, was fed by oxidizer and fuel tanks, and was controlled from the cockpit. The fuel rails surrounding the shell provided combustion to the four thrusters. The RCS system was manipulated using the Altitude Translational Control Assembly joysticks. These manipulated the thrusters to direct pitch, yaw, and roll. The hinges of the forward hatch and the plate for the cam latch are secured to the inside by spring-loaded, quick-release pins, which, in an emergency, can be pressed in and removed. The entire hatch can be taken off, allowing for exit from the lunar module. The pressure release valve is found on the hatch, which can be operated from both sides. The rendezvous radar antenna works on a gyro system, so it's always in direct communication with the command module in orbit. No advanced computer console is complete without the vital input from Dr. Tahiri. The crown jewel of our assembly, the docking system, is based on the International Space Station's assembly instead. We couldn't source any 60s YouTube videos or microfiche, so took rough dimensions and made it work. The tension springs and hydraulic cylinders provide smooth articulation and maneuvering, and collapse into the ascent module when not in use. The upper access hatch, located below the docking mechanism, served as the only thing keeping the astronauts from the dead cold of space. There are small air vents on the sides to help relieve pressure when mated with the command module. The pressure relief valve relies on the spring, which keeps a pressure cone blocking the airway. When the handles are pulled, the spring is compressed and airflow is free to move.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.